two brothers, Owen and Peter, began work in 2005 on starting salaries of €20,000 and €17,000 per annum respectively. So per annum means per year, and respectively means the first name was Owen, so his starting salary is the first amount, which is 20,000, and the second name is Peter, and his starting salary is the second amount, which is 17,000. Owen's salary increased, so went up, by €500 per annum, so per year, and Peter's salary increased, went up, by €1,250 per annum or per year. This salary pattern will continue. So here we have question A, B, C, D, and E. And on the next slide, we have F, G, and H. So press pause and have a go at them, and when you're ready for the solutions, press play. And here are questions F, G, and H. So again, press pause and try them, and when you're ready for the solutions, press play. So part A, complete the table showing the annual salary, so the yearly salary, of each brother for the years 2005 to 2010. So we have the years 1, 2, 3, 4, 5, 6, Owen's salary, Peter's salary, and then part B, in what year will both brothers earn the same amount? So I would start this question off by writing 05, which stands for 2005, beside the number 1, which is year 1. So they began work in 2005, so 2005 is year 1, or term 1, since we're looking at sequences. So then year 2 is 2006, year 3 is 2007, year 4 is 2008, year 5 is 2009, and year 6 is 2010. So Owen's salary started at €20,000, but it increased by €500 per annum per year. So we're going to add €500 to 20,000 for each term. So 20,000 plus 500 is 20,500, and then plus another 500 is 21,000, plus another 500, 21,500, plus another 500, 22,000, and plus another 500, 22,500. So then Peter's salary increased by €1,250 per annum or per year. So remember, he started on €17,000, so we're adding 1,250 each time. So 17,000 plus 1,250 is 18,250, plus 1,250 is 19,500, plus 1,250 is 20,750, plus 1,250 is 22,000, and plus 1,250 is 23,250. So part B, in what year will both brothers earn the same amount? Well, the answer is 2009. You can clearly see that they will both be earning 22,000 in 2009, which is the 5th year. Part C, Owen claims that their salaries over the years can be represented by an arithmetic sequence. Part 1, explain what an arithmetic sequence is. Part 2, do you agree with Owen? And explain your answer. So, explain what an arithmetic sequence is. A sequence, an arithmetic sequence, is a sequence where the first difference between each term is the same or constant. And do we agree? Do we think it is an arithmetic sequence? Yes, we do. A constant amount is added to his salary in any year to give his salary for the following year. So his salary went up by the same amount every single year. So therefore, it is an arithmetic sequence. This is also known as a linear sequence. And if we were to draw it out on a graph, it would form a straight line. Part D, find in terms of n a formula that gives Owen's salary in the nth year of the pattern. So basically, find Tn, the nth term. So focusing in on the row that relates to Owen's salary. So I'm going to take the terms starting with 20,000 and write it down here. So T1, term 1 is 20,000. term 2 is 20,500, term 3 is 21,000, and so on. So this is one way to get the nth term, or Tn, and it is to, first of all, get the difference between each term. So the difference is 500. We're adding on 500 each time. So we write down the number 500. Step 2 is you just stick on an n, so we have 500n. And step 3 is you get the zero term. So you start at term 1 and you go backwards by 500. So since each time we were going up by 500, we're adding 500, now we subtract 500. And 20,000, take away 500 is 19,550. And we just add that number on. So that's the shortcut way to get the nth term, or Tn. And now I'm going to show you the way using the formula, which is in the formula book. So again, we start with the sequence. So we've got 20,000, 20,500, 21,000, ... We get the difference between the terms, it's 500, we call that D. And we let the first term be A, so 20,000 is the A. Next we write out the formula. So Tn, the nth term, equals A plus bracket n minus 1 bracket D. So next we're going to sub into the formula, swapping the A for 20,000 and the D for 500. So we have 20,000 plus bracket n minus 1 bracket 500. So we bring down the 20,000 and the plus, and then we multiply out the brackets. N times 500 is 500n, a number times a letter, we stick them together. And minus 1 times 500 is minus 500. A minus times a plus is a minus. Now we simplify. So we write down the 500n, and then we simplify the numbers. So 20,000, take away 500, is 19,500. And now we've worked out Tn, the nth term. So question D asks us to find, in terms of n, a formula that gives own salary in the nth year of the pattern. So basically find Tn, the nth term, and it is 500n plus 19,500. Or you can write 19,500 plus 500n. Part E. Using your formula or otherwise, find own salary in 2015. So our nth term, our formula, is 500n plus 19,500. So if we can figure out which term of the sequence will be 2015, we can swap this n for that number with brackets and multiply it out. So it's not going to be 2015. So year 1, or the first term, was 2005. So 2006 was year 2, or term 2. 2007 was year 3. 2008 was year 4. 2009 was year 5. 2010 was year 6. So 2011 will be year 7. 2012 will be year 8. 2013 will be year 9. 2014 will be year 10. And 2015 will be year 11. So year 11, or term 11, equals 2015. So we swap that n for brackets and we put 11 into it. We do not put 2015 into it, we put 11 into it because it's the 11th term of the sequence, or it's the 11th year from the start. Remember, the start was actually 2005. Then we multiply 500 multiplied by 11 plus 19,500 is 25,000 euro. So in 2015, own salary will be 25,000 euro. F. Find, in terms of n, a formula that gives the total amount earned by Peter from the first to the nth year of the pattern. So when we hear that we're interested in the total amount, this means that we're going to add. We're going to add up all the salaries. We're going to add up all the terms in the sequence. And when we're adding terms in a sequence, it becomes a series. And when we're adding series, this is also known as summing the series, we use the sum of series formula, SN, from our formula book. So here we have Peter's salary. So we know he started on 17,000 and he added 1,250 each year. And we're going to use the SN formula from our formula book, which is n over 2 times 2a plus n minus 1 times d, where a is the first term and d is the common difference. So the first term is equal to a, which is 17,000 euro. So here's our a, 17,000 euro. And the difference, which is equal to d, is 1,250. So the difference is 1,250. We added on 1,250 each year. So we have our formula, and we don't sub anything in for the n, because we're actually trying to create a formula in terms of n. That means n will be in the formula. So we want n in our answer. So we have n divided by 2, so that just stays as it is. Then we bring down that bracket, and then 2a becomes 2 multiplied by 17,000. So we swap the a for 17,000, but we must put brackets around it because we're multiplying. Then we bring down the plus, the bracket, the n minus 1, the other bracket, and then we swap the d for 1,250. That was the difference. So then in the next step, the n over 2 stays the same. Then 2 times 17,000 becomes 34,000. And then n times 1,250 becomes 1,250n. And minus 1 times 1,250 becomes minus 1,250. So next, n over 2 will become a half times n, because n divided by 2 is the same thing as a half multiplied by n. And then 34,000 minus 1,250 becomes 32,750. And then we just bring down the plus 1,250n. So we have a half n multiplied by 32,750 plus 1,250n. And to just simplify it a little bit more, we're going to multiply in the half n. So a half n times 32,750 is 16,375n. So basically a half of 32,750 is 16,375, and then we just stick the n on. And then a half n multiplied by 1,250n gives us 625n squared. So a half times 1,250 is the same thing as a half of 1,250, and a half of 1,250 is 625. And then n multiplied by n is n squared. So here we have our answer, our formula, Sn, which is a formula in terms of n, so that means n is in the answer. And this will give us the total amount earned by Peter from the first to the nth year of the pattern. So the first up as far as whatever we want. So, for example, if we wanted to work out how much Peter would earn in the first 10 years, we'd swap both of these n's for 10 with brackets around it and then just multiply it out. If we wanted to know how much Peter would earn in 20 years, we'd swap both of these n's for 20 with brackets around it and multiply it out. Part G. Using your formula or otherwise, find the total amount earned by Peter from the start of 2005 up to the end of 2015. So we know that from 2005, 2006, 2007, 2008, 2009, 2010, 2011, 2012, 2013, 2014, 2015, there are 11 years in total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 years in total. So we take our formula for Sn that we worked out in the previous question. We swap that n for 11 with brackets around it. We swap that n for 11 with brackets around it. and then we multiply it out. And we can use a calculator. We get €255,750. Now alternatively, let's say we hadn't been able to figure out this formula. What we could do is work out S11. So we could go back to our original sum of series formula, so our SN formula, and we swap the A for 34,000. We swap the D for 1,250, and we can sub in 11 in place of both ends, and it will still give us the same answer. Part H. Give one reason why the graph below is not an accurate way to represent Peter's salary over the period 2005 to 2011. So here we have an XY axis. So the x-axis shows the years from 2005 to 2011. So 05, 06, 07, 08, 09, 2010, 2011. And the y-axis shows the salary in euro. So starting at 0, going up by 4,000, 8,000, 12,000, 16,000, 20,000, 24,000. And we see that we have 6 points, 1, 2, 3, 4, 5, 6 points, and they form a straight line. So we need to say why this graph is not an accurate way to represent his salary. So, although Peter's salaries sequence is an arithmetic sequence, which is also a linear sequence, and it should show a straight line on a graph, we have to be a bit careful with this, because remember, Peter's salary only increases at the end of each year. So it's not going up by a steady amount every day or every month. So for example, between 2005 and 2006, if we zoom in on this, we can see that we have a steady line, a constant line that is going upwards, and that obviously continues throughout the next few years. So this would indicate that his salary is going up daily by a small amount each day. But we know that his salary actually increases at the end of the year. So a more accurate graph would look like this. So this would show us that his salary stays the same for the full year of 2005, and then it goes up at the end. It goes up to the next salary point. And then again it stays the same for 2006, and it goes up at the end of the year to the next salary point, and so on. So although linear or arithmetic sequences should show a straight line if they're drawn out on a graph, in this particular question it would not. So the answer that we're looking for is something similar. So to give one reason why the graph below is not an accurate way to represent Peter's salary over the period 2005 to 2011, the graph shows Peter's salary increasing constantly throughout the year, but his salary only increases at the end of each year. So therefore that black line is not an accurate way to represent his salary.